Hello, my name is Valeria Torres. I'm a fifth year student, double majoring in mechanical and aerospace engineering. One big part of many space missions is the efficient execution of a rendezvous maneuver. In research, this maneuver is often modeled as a linear approximation. However, in this particular research, this maneuver was modeled using both a linear and nonlinear approximation. The Clohesi-Wiltshire, or also known as CW equations, were used for the linear modeling. The equations used for both models can be found under the methodology section in the poster. The results obtained through both models were plotted against each other. Figure 1 is the displacement versus the time, and Figure 2 is the velocity versus the time. The solid lines correspond to the XYZ components obtained through the linear model, and the dashed lines correspond to the XYZ components obtained through the nonlinear model. To determine if a linear model is a good approximation, both the nonlinear and linear solutions should be very similar to each other. However, in this research, that was not the case. If you look at figure 1, you can see how the nonlinear rendezvous time was about 200 seconds larger than the linear rendezvous time, which means that the path taken using the nonlinear model was less direct. This research showed that modeling a rendezvous problem using a linear approximation might not give the most accurate solution since it doesn't take into account the effects of gravity on the spacecraft. The CW equations are used when formulating spacecraft rendezvous approximations when the target is on a circular orbit. Although the CW equations are a commonly used approximation, in this study the difference between the solutions were much larger than we were expecting, which means that the CW were not a good approximation. This was the biggest takeaway of this study. Thank you for listening, and if you have any questions, I'll be more than happy to answer them. Have a good day.